So of course I'd like to start by saying thank you everyone for joining. My name is Cody Armstrong and today we're talking about using the transform command in Onshape. And so we're going to walk through all the various scenarios where you can use the transform command, why you might need to use it, and just some common techniques that I've found for using the transform command. So just again, another frequently asked question that we get from users: how do I position parts in my part studio? How do I move parts around inside of the part studio? And that's of course the transform command. I'm going to walk you through a few various examples of it. So let's get started now. Just briefly, before I get into the topic of the day, real quickly an agenda. Of course, I want to introduce you to the transform command. That's goal number one. We're going to walk through what is a transform and why you would need it. Why it's used is a very important part. So why you need it is what we're going to be discussing here today. And then, of course, how you use it. And I have a few simple examples, but it just depends on the type of geometry you're working with in the scenario. So I have a few different examples to show you. So that's a real rough agenda. Not going to use the entire hour here today. Really just going to show a few of the various ways that you can use transform. All right, so moving on. What is transform? And to put it simply, it's a way of positioning your part within a part studio. So it's a way to adjust a part's location and its orientation in the part studio. And it's important to keep in mind, we're not talking about assemblies today, just part studios. If I need to move parts around within the part studio. Now, you also have an option to copy the part. So technically, this could be considered some type of a pattern. You can use it to create a copy. So it's an important thing to consider with the transform as well. But it's, again, very simple. You're moving a part within the part studio. And if you do a lot of part modeling with respect to other components, a lot of what's called top-down modeling, where you model with respect to other parts, this is going to be a very important command to you. So that's a simple explanation of transform. Again, just moving your part around with respect to the part studio. But why would you need it? And I mentioned it briefly, but a lot of users build parts around other parts, right? If you build, a housing, it's going to house something, maybe a motor, maybe a gear, all kinds of different things. But you're building your geometry around other parts. And I think it's a very common workflow, whether those parts you modeled or parts you imported, the workflow is going to be the same, and the example is really the same. I need to build you'll see the housing on the left there, around these worm gears. These worm gears perhaps came from a library of files from another system, but I need to build my housing around it. A great example where I need to insert the gears and position the gears in the correct position in the part studio so that I can correctly model my pieces around it. So I think, the most common example I can give you for using the transform command is positioning parts so that you can model your geometry around them. Building parts often referred to in a top-down modeling approach. Okay, so again, building parts with references to each other means you'll need to position them in the correct place before you can do that. Now, as I mentioned, they can be imported geometry, so you can bring in data from other CAD systems and position in a part studio and model around it, or it can be parts from other tabs in your document or whole other documents. So you can insert, other parts within the document as well. So these are just a few examples where I think transform really makes a big difference. So this is where oftentimes users start asking, why would I need it? What am I going to use it for? Well, if you need to move parts around into your part studio, this is the command to use. So that's why you would need transform. Now, how would I use it? And it's really, you have just a few set of options. You have transform by line, which allows you to transform a part based on line geometry. The length and the orientation of the line define the transform. And transform by distance, where you can transform parallel to an edge, for example, a given distance. Transform by XYZ, as the name implies, allows you to transform by XYZ location. And then finally, transform by mate connectors, it allows you to define a part's location based on mate connectors. Now, I've highlighted transform by mate connectors for a reason. It is by far the most friendly technique for positioning, especially complex orientations where I might need to do 2 or 3 transforms using line and distance and so on. And it's complex. It's hard to position a part using those commands. Transform by mate connectors makes it very easy. So I'm going to show you 2 examples of transforming using a mate connector. But again, if you're doing a lot of this type of work, it's the tool, it's the one option that I would recommend within Transform. Now, there are other options within the transform command, like rotate. If you just want to rotate a part around, you can do that. You can also just simply copy it and create a copy in place. And that, of course, like the name implies, give you a copy of your part or parts in the same exact position as the originals. And then finally, scale is also inside of the transform command. This is another frequently asked question that I get. Can we scale parts in Onshape? And the answer is yes, absolutely. It's in the transform command. You'll see a command called scale uniformly. And I'll show you an example of this in just a bit. But these are your options for the transform command. I'm going to walk through as many of them as I can in the time that we have. And I'd like to start with a simple transform by line. So let's jump over to a document in Onshape. And what I'd like to do, you'll see I have a simple U-bolt shape. And what I'd like to do is transform. You'll see I have a thread profile here. Transform it to the other side. Now, the first question I often get asked in a scenario like this is, well, why would you just use a pattern? Couldn't I take the thread and pattern it to the other side? And the answer is yes. And like many things, there are different techniques that you could take. I would say the transform gives me one additional option. By defining it with a line, if the line changes, the transform updates. So transform by line is oftentimes a much smarter approach than transforming by a set of values, 1 inch this way, 2 inch that way, because they're not intelligent. They don't update if the other geometry changes. Transform by line allows me to define a line, say this is the direction and orientation that I want to transform, and if the line moves, the transform will automatically update. So this is the first one, the first option that you have in the transform command. So you'll see the transform command right here in the center of the toolbar. I select transform, and as I mentioned, the first in the dropdown is transform by line. Now it's a really simple command. I select the part that I want to transform, part or parts, I should say, and then in this case, translate by line. And you can also translate by points, by the way. But very simple. You select your line, it transforms that thread definition to the other side. It's important to keep in mind that it's moving this part based on the line definition, but it's not keeping the original, so to speak. In my case, there's also an option, copy part, that allows me to keep the original part plus have a copy at the end of the transform line. So if you're looking to copy a part, you can do that as well. You'll see the copy part option in a number of the different translate drop-down menu options. But it's a very easy way to keep the original, like in my example here. But again, the line really drives everything. So, if I were to go in and make a design change to this, let's say this was, 2.25, green check, everything would rebuild. So I don't need to reposition my patterned instance. Okay. So in this case, the transform body, because it's dependent on the line, updates the way it would expect. If I had just done a simple pattern, for example, I would not have gotten that. So that's the first one, transform by line. Again, just taking a part, transforming it based on the direction and distance of a line. All right, so moving on, that's transform by line, the first option that I want to discuss. Now, the other two, the next two that I should say that I want to mention are relatively simple, and there are 4 examples where you just want to shift a part either along an XYZ or along a certain direction. So think of a scenario where, I just want to take 1 or 2 parts and shift them this way an inch or 2, not very complicated transform, but a very easy one. So let's select transform. And the next one in our list is translate by distance. Okay. So I can translate by distance, and this will allow me to specify a direction. Okay. So again, same step as before, define the part or parts that I want to transform. In this case, we'll transform the V block and the brace between the frame here, and then I'll specify a direction. I'll select direction, then just click on any edge that represents the parallel direction that I want to transform. In this case, I'll select this edge on the beam. Notice it then transforms 1 inch that geometry. Let's make it 3 inches. So now I'm transforming both of those parts 3 inches in the direction of the edge that I've chosen. So again, very simple command. You're using a static number, a distance value, but a very easy way to just shift something a simple amount, an inch, for example, parallel to whatever you select. So that is translate by distance. Transform by distance gives you that ability to just specify here's an edge, here's a distance, move parallel to that edge, this much distance. Okay. And of course, you can hit the green check and you have your finished transform. Now, that's one method for accomplishing this. Another technique that you could use is the option just below that, which is translate by XYZ. And this allows you to transform parts based on XYZ positions. And so very simple, translate by XYZ. Again, select the parts that you want to transform. Then just set the X, Y, and Z amount of translation. So the amount of distance that you want. And so in this case, one quick reference users often ask, how can I tell what's X, what's Y, what's Z, is the cube in the top right will give you that visual cue. Okay. So in this case, let's do a -4 offset in the Y. So this is in the Y axis, -4 inches. I'm transforming those two parts. Okay. Question, is there an arrow on edge to show which way it's going to move? You do have a drag arrow, by the way. So I can grab this and drag it if I don't want to enter a certain value, or if I'm just curious which direction moves which way. The manipulators on transform make it easy to grab and drag. So that is a simple translate by XYZ. And again, all you're doing is saying I want to move in this direction, this certain amount. Now, if you're trying to move in something that's not an X, Y, and Z direction, parallel to an edge, for example, this is not an ideal solution. So the example I was giving you a moment ago, if this entire assembly were at 45 degrees to what it is now, I would be using translate by distance and clicking on an edge rather than XYZ. So this is a great command when the direction lines up with X, Y, and Z. But if it doesn't, you'll need to use something like a translate by distance and click on an edge. So is there an arrow on edge to show which way is going to move? When you're doing a translate by distance and specifying a direction, you do get an arrow. Okay. I can left click the arrow, by the way, as a way of flipping that direction. But when you're doing a translate by distance and you click on an edge, you do get the same manipulator arrow. Now, in the case of translate by distance, of course, you only have a single direction because it's referencing the edge, but it's an easy way to tell which direction that it's going to move. Is the word transform just another way of saying move? It is a simple way of explaining it, yes. There are other things that transform can do, like scale, copy and place, that aren't necessarily just moving. But yes, that's a simple way of explaining. All we're doing is we're taking parts and moving them within the part studio. And again, just stressing that none of this applies to the assembly. Moving a part in an assembly is a matter of just left click dragging or moving with a triad. But in the part studio, you'll need a transform. So again, simple translate by distance, translate by X, Y, Z. Okay. Now another question, is this the same as pattern? The answer is no. Now you can pattern. I can check copy parts, right? And that will give me multiple instances too. But if I need 3, 4, 5, 6, then I can't do that with transform. So that's one limitation with transform. You can't specify number of instances, right, and continue patterning. So you would need a linear pattern or a circular pattern to accomplish that. But there is an option to copy part, and that's an important thing I want to stress with the transform command. You don't necessarily need a pattern if all you need to do is one more instance along an edge, for example. You can just use a simple transform, check copy part, and you'll get that end result. So this is transform using a direction, like an edge on a beam, for example, or transform using X, Y, and Z. And again, it's just referencing the X, Y, Z orientation of the model itself. In both of those examples, you're using a simple number to set the amount of transform, the amount of translation. 1 inch, 2 inch, 3 inch. And in both of those examples, they don't necessarily update well. And so a translate by line, the first example that I showed you, because it's based on sketch entities, will change if those sketch entities change. So it allows you to build a little bit more design intent in. But all of these scenarios that I've shown you up to this point are particularly difficult if we're talking about complex movements within the Part Studio. Simple shift over a certain amount or shift up a certain amount is easy. But what if I need to shift over, rotate, and I need to translate in all directions and rotate the geometry and get it in an exact position? That's where it starts to get a little bit more complicated. And there are users out there doing, figuring out the exact distances between faces and so on, and doing a transform that way. But there's a much easier solution, and that's transform using mate connectors. Real quickly, a question. When you copy a part, will the changes to the original part propagate into the copied part? And the answer is no. And that's an important thing to point out. It is not dynamically changing based on changes to the original. You could use a derived part, and that's a different discussion. We're going to, I'll show you an example of this in a bit, but you could use a derived part and then pattern that, and you would get that behavior. You could transform that and would get that behavior. But the example I've shown you up to this point, no. Question, could you please state when it is better to use an assembly and when it is better to use the Part Studio? And this is a very good question. One of the first and most important things I would stress is when the most important thing to consider when you're asking, do I need to create an assembly? First off, do you need motion? Do you need dynamic motion? In other words, I need to be able to grab a part and move it up and down and see it move dynamically. Or do I need to animate motion? Those two things can only be done at the assembly level. So if your design has motion and you want to test that motion out, either just grab or drag or animating it, you need to create an assembly. The other thing to consider is in the Part Studios, it's really only important to model a single instance once. So if I were modeling this Part Studio, for example, really I have this V block and this frame piece. I have them patterned several times, but it's really quantity 5, instance 1, right? At that level, you want to insert those instances at the assembly. And we have lots of pattern techniques to help you handle multiple instances of a part. Another example I like to give is, putting a bolt in a hole. If you have a dozen bolts that go into your assembly, it's best to do that at the assembly level, not in the Part Studio. And the main reason for that is when you go to create bill of materials, your quantity counts will be correct and so on. So again, assembly motion, that's step number 1. If you need motion dynamic, you need to create assemblies. And also, if you have multiple instances of parts, like I have in this example, where I have maybe a half a dozen V blocks, I would create an assembly and pattern those parts so that, again, the quantities are correct. So, moving on. Now, these are relatively what you might call dumb transform commands up to this point. They're just based on numbers. I'm transforming 3 inches that way. And so it doesn't really update when things change. It doesn't behave well to, reflect my design's intent. Transform by line is a little bit better example because it's based on a sketch, right? So if I update the sketch, the transform will automatically update. But really, all of these solutions so far are great for simple transforms. What if I have something a little bit more complex? And so an example I often give is, what if I need to import geometry from some other CAD system? And it's not going to come in the right position. And I got to put these parts together, and I need to model a flange for them, let's say. So I have a top casing, a bottom casing, and these were imported Parasolid files. So these were files that I got from someone else. I've imported them into Onshape, and now I need to put them together and model a flange around them. The key thing here is you're going to use the derived feature to insert parts into your Part Studio. So in my case, that's step number 1. I need to take these two Parasolid files that have been translated. You'll see bottom and top casing. I need to put them together in the same part studio and then model my part around them. The problem with this, and the problem that you'll inevitably run into, is when you go to use a derived feature and you select, for instance, the bottom case, and I insert it, it's not going to come in any position relative to my assembly. Remember, it comes in the position it was originally modeled. And if that wasn't done in a way that makes sense, unfortunately, your model is going to come in a way that it doesn't make sense, right? So you'll see I've derived these two parts into my part studio. The problem I have, of course, is now I need to position them relative to each other. And if you look at it, it's a complex series of steps. I would need to rotate this around, and then I would need to shift over, up, down. So I would need a series of transforms to accomplish this, given what I've shown you up to this point. Okay. Questions. How do you get beams in the part studio? And the example I was showing you a moment ago was just simple sweep commands of a rectangular sketch. And that's how I got those beams that you see. What is the recommended method for folding a flat part? For example, let's say I have a pattern for a cardboard box. Is it better to rotate, transform at the part level, or wait until the assembly and use mate connectors? You could potentially do that at the part studio level using mate connectors, given what I'm going to show you in just a moment. So bear with me for a second and see if this technique will work for you. I'm not sure if others have lag on the screen, but if it loads, I'm still looking at the V-block example. Forgive me if the video is not updating for you. I am showing a different example than the V-block. Okay, so I have these two parts. They're clearly not in the right position. I need to get them into the right position so that I can make my part around them. And as I mentioned before, everything I've shown you up to this point, it would take quite a few steps and quite a few calculations to figure out how to get it in the right spot. So how do you handle situations like this where it's not, one direction, very simple? The answer is using transform by mate connector. Now, this takes a little bit of setup, a step more than anything we've done up to this point, but it's much, much easier than trying to figure out what the XYZ rotation values are to get your part in the right spot. So let me show you how this will work. Now, this is very similar to mates in an assembly. And so it's not mates in an assembly, I want to stress that, but it's very similar to it. So if you were to think, I want to fasten this part to that part, that's essentially what we're doing with the transform by mate connectors. There is, however, one important prerequisite, and that is you have to have mate connector. You have to have one defined. And so what I'd like to tell users is go through your parts and add a mate connector at that attachment point between the parts. In this case, I'll select mate connector. In this case, I want to attach the center of this circle to the center of the circle on the base. So I'll left click here and it will place a mate connector at that point. Green check. Now I have a mate connector in one part. Let's jump over to the other part. And now I can insert mate connectors here. Okay. The key thing, the reason this is important is as I go in and start to position my parts in the part studio, it's much easier to say just bring these two mate connectors together than it is to say move X over this amount or move by this line. So in this case, I can say, okay, transform. This time we'll use transform by mate connectors. Then I'll select the top part as the part I want to transform. And then it's a matter of from to. So from what mate connector to what mate connector do you want to transform? In this case, I'll select transform from this mate connector to this one. Okay. In this case, let's go from here to here. Okay. Now, it will bring those two parts together, but don't worry if initially the alignment isn't 100% correct. There are a few things that you can do. You'll notice my orientation is essentially upside down. There is a simple flip the primary axis option in the transform command, and that allows you to flip the quote-unquote Z axis of the mate connector. And so that may give you a simple way to get it correct, like in my example here. You can also orient the secondary axis in different positions. So if it's off by 90 degrees, for example, I can position it in 90-degree increments until I get it correct. But there is something else that you can do, and this is something, especially if it's not, again, a simple 90 degrees or flip direction, you can also do things like edit the made connectors and offset them. Okay. And so, I'll go over an example of this in just a bit. So bear with me. But again, just using the transform, I bring the two made connectors together. Now, a tip is you can hide the actual symbols just by hiding the derived features that they were inserted with. But now I have my part mated together, so to speak, in the part studio. And now you'll see what I mean, but it's very similar to mates. Now you need to define the mate connectors beforehand, but then just bringing them together is very similar to the fasten mate at the assembly level. Just click the two mate connectors, brings them together. You can specify flip directions and secondary axis if you need to, and you can also edit the mate connector to get it exactly where you want it. And I'll show you an example of that right now. Now, a few questions that have popped up, so bear with me. Is there a way to have two identical parts kept symmetrical about a plane or mate connector, i.e. cylindrical mounting gear modeled and positioned on a base plate and then inserted into an assembly and grouped? Both are fastened symmetrically to the origin. A second ear is inserted. I want to be located opposite to the first ear. That's a good question. Of course, you could do it at the part studio level, but the question is, can you do that and have it mirror at the assembly level? We don't have a dedicated command for mirror at the assembly level, so I'm not sure, not off the top of my head, how I might get that. I'm sure there might be a technique I could use using maybe like a planar mate, or it would be something I'd have to look into a little bit more detail. Question: if the parts were not aligned in rotation, how do you place the mate connectors? You can position mate connectors using just about anything as a reference. So I used, just cylindrical faces in the center of those cylindrical faces on the parts to define where my mate connectors are. But keep in mind, you can move those around, and I'll show you that in just a second. Now, question: if you needed an offset for a gasket, would you create an offset plane or create two mate connectors? If I needed an offset, I would actually introduce an offset into one of the mate connectors to give me that gap between the parts. And by the way, I know I didn't mention this in great detail, but the reason I might want to do this, the reason I might want to bring these two parts together is maybe it's my job to build a flange. And now that the two parts are together, I can start to, sketch my geometry and attach it to the correct places with respect to these imported models. And I think this is a common workflow. Whether you're working with pumps, motors, bolts, it really doesn't matter. If you're building any kind of geometry around something either that you've modeled or that has been imported, you'll need this technique. Right? And so now I'm converted entities. I'm attaching geometry to these imported models that are positioned using transform, and now it's easy for me to just click extrude and maybe extrude out a simple flange. Right? And so now I've taken two parasolids, brought them into a document, positioned them using transform with mate connectors, and I've modeled my flange around them. Question: if you transform part A to part B using a mate connector, can you transform part A with a mate connector, let's say to the origin, and then part B will come with it? Yes. So the two are dependent on each other. So you are creating that effect. I could then take this and transform it together. Now, it's important to keep in mind it's not a dependency, so to speak. It's not one dependent on another, but I could then take these and transform them all using a simple transform. Everything I've shown you up to this point, remember, you can transform multiple parts at once. All right, so moving on, that is transform using a mate connector. And again, the key thing I want to stress there is, maybe you've imported models like I've done here. Maybe you've got models from other, libraries of data, and you need to be able to position it within your part studio. Transform using mate connectors or transform by mate connector in the translate command or the transform command is by far the easiest approach to complex translations like this. Again, if you're just trying to do a simple long and axis, there's an easier way. But if it's something like this where it's not easy to figure out how much rotation, how much X, Y, and Z, then transform and mate connectors is definitely the approach you want to use. Now I have one more example, so bear with me. Here's an example where I'm modeling a power drill, and I need to define the power drill's size, maybe the location to mount the motor in the actual frame or the shell for this power drill. And you'll see I've derived this power drill into the Part Studio. So here's the derived feature where I insert the motor, but it's nowhere near its right position. And I need to model maybe some bearings around these axles. I need to make sure I have clearance in the shell itself, maybe even modify the shell to match this motor. And so, of course, the first step is for me to transform this motor into place. And here's another example where it's not really clear, what's the X, Y, and Z. Maybe I can translate by line, but it'd be much easier just to define a mate connector on either point and transform using that. So, question, is there any sliced view mode? Suppose I would model something inside of the casings. In this example, I would just hide and show parts. You can, of course, section view. We have a section view command in there as well. Next question, can you transform the first part to the origin? Yes. It'd just be a matter of defining a mate connector using the origin as your reference. That's the way I would recommend. Again, just a simpler approach. But you could do another transform and transform that part over as well. So if you were really concerned about its position on the origin when you imported it, I would first transform to the origin and then insert your transforms attaching the parts to that one. So another example, again, I have this electric motor. I've brought it into my Part Studio, but it's completely away from the origin. The origin's down here around the power drill. I need to insert this part into the shell and make sure that it fits. Right, so there's actually two pieces to this drill body. I need to make sure that it's not colliding with anything, and maybe model a bearing or some kind of housing around that. So what would I do? And this is another example where I'd use transform by mate connectors or translate by mate connectors. And it's easy to take something like this electric motor and say, okay, here's the end of the shaft, and that's really what I care about. So let's define the end of the shaft here. And that's my mate connector. And let's go back to the power drill itself, and I'll insert a mate connector where I want to attach that end of the shaft. Now I select mate connector, and let's say I want to attach it to this, center point of this cutout in the frame where the shaft goes. So very easy for me to place my two mate connectors. Now, one thing I want to point out is the end of that shaft should actually extend past this point that I've selected. And I mentioned this before, and it's come up in a question. What if I needed an offset? Or what if I needed, not to bring the 2 points together, but maybe a ½ inch between the 2 points? And you can do that with move. So I can check move while defining the mate connector and say, okay, I want, let's say, -5/8 translation in the mate connector. Or let's say positive 5/8.625. And you'll see that mate connector shift away from the origin. So it's a way to add an offset so that now when I attach my point, the end of the shaft is going to be here and not exactly at the end of that rib. So just keep in mind, you can adjust the mate connectors, give them exact offset values or rotation values, and it makes positioning the part in the exact right position, the first time very easy. So I've defined these two mate connectors. Now all I need to do is, again, use transform. I want to transform the electric motor by mate connectors. Okay? And I want to define from this mate connector to this mate connector. Okay? That will, of course, take the motor, place it at my specified point. Right? Green, check OK. And now I've placed the motor, and I can begin constructing my bearings or my various mounts or making sure that I don't have any collisions. You can see it's sticking out of the frame there. So it's an easy way to start modeling around this motor and getting it to the shape that I want. Okay. All right. Question, what would be the command to transform between points? You remember that the translate by line has an option to specify points. So just keep in mind, I would use translate by line and click the point instead of a line as your reference. Another question that comes up, how do I check for interference? And there are a few techniques. You can see, obvious interferences here, when I grab and drag a section view. One thing I always like to point out is in a section view, anything that's overlapping will show in a different color than the surrounding parts. It'll show in this specific color. So just keep in mind, when you're in a section view, anything that's overlapping or interfering will highlight in a different color. Okay. All right, so moving on. The destination make connector is the last one chosen, correct? And the answer is yes. And it's an important thing to keep in mind when you're doing this. The transform command is a from to. So from one mate connector to another mate connector, and thinking of it as a destination is an accurate way to think of it. So that is transform using mate connector. I've shown you two examples of it, mainly because I think it's a much more common technique for using transform in examples like this, where it's not obvious a single direction, a single distance, and so on. Okay. Yep, it looks like you should have moved the housing along the X, not the Z. No, it's just that I don't have enough travel here based on the geometry that I've specified. So in my case, now I need to know, I need to redesign the shell to wrap around this frame. But of course, that's design intent, right? It depends on what your goals are with your design. I could swap out the motor knowing now that I don't have the right one, right? So it's entirely up to me to design that. But just keep in mind, the neat thing is I can see it. I can position it, and I don't have to base it on, static specs from a spreadsheet, for example. When you say line, does it have to be linear or can it be a trajectory? No, it needs to be linear, a line. All right, so we've discussed all the ways that you can transform parts, and that's just, ways that you can position parts in your Part Studio. Now, there are a few things that I want to point out with the transform command that don't necessarily have to do with moving parts. There are a few, well, I should say one more regarding moving parts. If you need to rotate a part, it's very simple. You can select rotate, select a part that you want to rotate, an axis to rotate about, right? So I can select an edge, for example, and it will rotate about that axis. So it might be an easy way for me to offset in, for example, 5 degrees with a rotation about the top line of this edge. So just something to consider if you just need a simple way to spin a part around or rotate it around an axis, you can do that. But there are other options that I do want to mention here. In particular, copy and place and scale uniformly. Copy and place, like the name implies, will just give you a copy of your part. So you simply select a part and it gives you a copy of that part. This is useful if you're using multi-part techniques as like tools, where I want to take one part, transform it over here, and maybe subtract it. Or merge it. So, all kinds of examples where I would just want to take and maybe insert a couple instances of this part, move them to certain places, and then, do something, Boolean operation, for example. So copy and place, like the name implies, just gives you a copy of the part in the same exact spot. Now, the other one that I want to mention is scale uniformly. And this is something that a lot of users ask, especially if you come from certain industries. So I have an example of this, and I actually have a slide, so bear with me for just one moment. So scale. Real quickly, before I get to scale, questions. How do you turn off the mate connectors? I should have gotten to that before I jump back to my slide. In the case of the mate connectors, you can hide them. So there's a little hide icon if they're derived. So if I insert a mate connector that's derived, I can hide it as well. But it's just a matter of clicking the I symbol next to the mate connector in the feature list. Question. I think the last question about moving in the wrong axis relates to the fact that the mate connector and the part direction have different system of axis. Is there a reason for that? You can align a mate connector with any axis of a part that you want. So you can reference anything on the part as a way of defining a mate connector. Now, it will come in the orientation it was modeled. So it was modeled in a certain orientation with respect to the X, Y, and Z. It comes in that same orientation. And that's the reason it may be off. A lot of times if, let's say that I designed something 5 years ago and another CAD application built all around other parts, it's not really going to have a relationship to the origin. And when I bring that in, it's going to be reflected here. And so that's a reason why it might not be in the right position. But I will say that when you go to define make connectors, like I was doing a moment ago, I could click an edge of the part and say that's the x-axis, or this is the y-axis. So it's easy for me to reorient a mate connector with respect to the part. Okay, so the last thing I want to mention is, again, the scale command. And this is a little bit different than some of the commands that we've talked about up to this point. Instead of moving a part or rotating a part or any of those types of things, this actually changes the geometry. It actually scales the part to match a certain factor that you've inserted. Now, this is a very common operation if you do any kind of mold design, injection mold design, cast mold design, where you have to deal with factors of heat shrinkage and accommodate for shrinkage within the design. It's also very common in 3D printing when you just want to simply scale something up, or if you've brought in geometry that needs to be scaled to a certain amount. Again, working with imported models. But think of any scenario where you need to adjust the scale, the entire scale of the entire part in one shot. The example I like to give is, I'm designing this power drill, and the power drill is an injection molded part. And when I'm designing the mold, I need to scale up by a certain amount to factor in that shrinkage that happens in the mold making process. Very common operation if you do these types of things if you're in this industry, but it's something that I want to point out. And again, it's within the transform command. Now, the scale command has really two options, three, I should say. What part or parts do you want to scale? What scale factor do you want? And oftentimes I hear users say, I want to scale it by 5%. Well, that would be a 1.05 scale factor. And then what point do you want to scale about? And it's important to keep in mind the entire part is scaled uniformly, and that's the nature of it. But you define a point that you want it to scale around. Okay. And again, as I mentioned, it's very common in certain types of industries. Questions, any way to scale non-uniformly? There's not a dedicated button for that, of course. We don't have a scale non-uniformly option, but you can absolutely scale parts as separately. I've seen that very commonly where I have multiple parts that maybe have different scales. I scale them as separate parts and then later boolean them together to make one. So there are different techniques that you could certainly adapt to, but not a dedicated command for it. And can you scale apart different amounts in different directions? And that's the same question, non-uniform, and the answer is no. Now, there are certainly techniques we could explore, like I mentioned, multi-part, where there's separate parts, and I scale them in different directions, and then bring them together. But there's not a dedicated command that would give me that capability. So again, real simple. If you want to scale a part, you select transform. You choose your part or parts that you want to scale. In this case, we'll select both halves of the power drill. And then I can say scale uniformly. Define my scale factor. By default, it's 1, which will change nothing. But let's say I want 5%. I change it to 0.05. I should say 1.05. And then define a point that I want to scale about. In my case, the origins right here at the end of the drill, it's a nice, easy reference. Okay. You'll notice it now scales the power drill to match that point. Okay. Again, you'll see it kind of in a transparent effect there. If I scroll this back and forth, you'll kind of see the beginning part and our finished scaled part. Okay. Now, of course, I can scale this by a lot. I'm giving you an example of an injection molded part that may have a small amount of scale, but what if I want to scale by, 25%, 1.25, and then let it grind away. It'll come back with a 25% scale. Okay. So again, very simple command, but I do want to point that out. Scale is an option within the transform command. It's a bit different than some of the other transforms. It's not really about moving parts necessarily, but scaling them, of course, right? So that's scale uniformly. It's the last transform command that I want to discuss. And I really tried to point out, a lot of the different examples where these things really come into play. But that's really what I had planned. I want to say thank you, everyone, for joining and sticking around. I am going to stick around and answer any questions that you have. So feel free to ask any questions in the GoToWebinar questions. I'm going to stick around and make sure they're all addressed. But that's it, everyone. I want to say thank you and have a good day.